Okay, let's do a few more examples. Fundamental theorem, how would I find the definite integral from 0 to 1 of x minus 1 times x plus 1 dx? Okay, so you're trying to find this definite integral, and you just have to find the antiderivative, right? The goal is, let's find the antiderivative. Now here, what you may be tempted to do, you may be tempted, is to say, well, you have these two pieces, the antiderivative of the first piece, I don't know, I could go and I could solve that, and it would be something like 1/2 x squared minus x, and then the antiderivative of the second piece is, I don't know, like x squared, 1/2 x squared plus x, there you go. And so the antiderivative is just the first piece times the second piece. But no. Why is that wrong? Like, what would you do wrong? Well, when I take the derivative of this, it won't be this. Because the derivative of a product, you have to do product rule. It's not just the first piece times the second piece. It's you hold the first, derive the second, plus you keep the second, you take the second one the same, you take the derivative of the first one, right? You have to product rule. And so when you find the antiderivative of a product, you can't do it like this. Instead, to find the antiderivative, first we're going to have to get rid of this product. The product rule messes us up. So you can't have this as a product. Instead, think of this as just the definite integral of times it out. Foil it out, multiply it out. X times x is x squared. Minus an x plus an x, those cancel, minus 1. This is just a minus b times a plus b is a squared minus b squared, right? So this comes out to be x squared minus 1. And now find your antiderivative. So this is just a reminder that when you have a product, you can't just find the antiderivative of both pieces. Rather, if you can, multiply it out, and then you can find the antiderivative. So this guy has antiderivative what? 1/3 x cubed minus x. And remember, for these, you don't need the plus c, because you're going to be doing plug in 1 minus plug in 0. Right now we're going to be doing f of 1 minus f of 0. So the plus c and the plus c would cancel with that minus. So you don't need the plus c. So what do we get? Well, you plug in 1 and you get 1/3 of 1 cubed minus 1. Minus plug in 0, that's just 0 minus 0, just 0. And so this comes out to be 1/3 minus 1, negative 2/3. Now, you do a quick sanity check. Negative 2/3. Why did it come out to be negative? Why did this area come out to be negative? Definite integral is signed area. And in this case, if you think about what your graph looks like, you're going from 0 to 1 of the graph of x squared minus 1. This is a parabola, but it's a parabola that starts down at negative 1 and then comes up. It's a parabola that comes up, starting at negative 1. And we found the area from 0 to 1. So we found this area from 0 to 1. And since that's area below the x-axis, it came out to be a negative number, right? Okay, so this came out to be negative because it's area below the x-axis. So just do a little reminder sometimes that this is signed area. Positive for above, negative for below. Okay, let's do one last example. We want to find the fundamental theorem. So let's do something like this. What is the definite integral from, say, 1 to 3 of x minus 1 over x plus 3? Again, you can't find, you're not going to be able to find f of x. You can't find your antiderivative by just doing the antiderivative of the top divided by the antiderivative of the bottom. It doesn't work that way, because when you do the derivative, you have quotient rule, right? Quotient rule makes it all messed up. And so you can't just do the top and the bottom. Instead, we want to say, is there some way for me to algebraically manipulate this? Just like here, I had to multiply it out first. Well, how can I divide this out? You could do it out with long division, right? But the trick here, to think about how to divide this, is to think, well, it'd be really nice if I had x plus 3 on top and bottom. I don't have an x plus 3 on top, but I can make it x plus 3 on top if I also then subtract 4. Because x minus 1 is x plus 3 minus 4. And then I can rewrite this as both of those divide by x plus 3. So this top is the same as x plus 3 minus 4, and then you divide both pieces by x minus plus 3, by the bottom, x plus 3. And that's the same thing as this. When you combine these, the plus 3 and minus 4 gives you x minus 1 on top. How does this help us? Well, it helps us in the following way. This simplifies to being just the definite integral from 1 to 3 of 1 minus 4 over x plus 3. And I claim this is something we can now find the antiderivative of. It's going to take some thinking, but the antiderivative of x, of the 1 here is just x, because the derivative of x is 1. So the first piece is fine, minus the second piece. What's the antiderivative of this? Well, okay, not obvious, but the trick here is to remember, if this had just been like a 1 over x, so like think back, the antiderivative, let's write this down here as like a little note. The antiderivative of just 1 over x, if it had just been 1 over x, or maybe I should write it like this, if my function is just 1 over x, if my function, g of x, is 1 over x, what would my antiderivative be? Well, then it would be the natural log of x. And a plus c if you need to write plus c. For these problems, we don't need the plus c. But just, it would be the natural log. The derivative of the natural log is 1 over x. Here it's very similar. If it was 1 over x plus 3, the antiderivative is the natural log of x plus 3. Because the derivative of this is 1 over x plus 3. The derivative of x plus 3 is just 1, so by chain rule, it's just 1 over x plus 3. This is good. It's just 1 over x plus 3, but I have a 4 on top, so to keep that 4, I multiply it by 4. Okay, so here I'm just reminding you how to calculate antiderivatives. The only challenging part of the Fundamental Theorem of Calculus is figuring out what your antiderivative is. But once you remember, this has antiderivative 4 times the natural log of x plus 3, now you're in business, because now by the fundamental theorem, this will be plug in 3 minus 4 copies of the natural log of 3 plus 3, that's 6. And then minus, plug in 1 minus 4 copies of the natural log of 4. Okay, and then simplify. So here we go. Kind of going meandering journey here, but now we should simplify. The 4 minus the 1, that gives you 2, minus 4 copies of the natural log of 6, 4 copies of the natural log of 6, minus 4 copies of the natural log of 4, so I can factor that out, that minus 4 out, so natural log of 6 plus the natural log of 4. And if you want to, you could combine those. Right, the natural log of a plus the natural log of b is the natural log of a times b. So this just ends up being 2 minus 4 natural logs of 24. Okay, however you end up writing it, you get your answer. So we just find the antiderivative, and then we plug in the bounds to it.